This last video in the triangle series could have appeared in either the triangle series or the circle series because it deals with what happens when you have a triangle inscribed in a circle. So this rule here might be considered more of an obscure rule, but I have definitely seen it show up from time to time. And I would say when it does show up, if you know the rule, it's usually going to be an easy question. But if you don't know the rule, it will be a near impossible question. So this is definitely a rule worth knowing. So what is the rule? It says, if you have a triangle inscribed in a circle, so what does inscribed mean? First of all, you have a triangle like this. This triangle is not inscribed in the circle. You would say this triangle is circumscribed by the circle. It is surrounded by the circle. A inscribed triangle has all of its edges touching the edge of the circle. So something like this would be an inscribed triangle. So if you have a triangle inscribed in a circle and it is a right triangle, then one of its sides is the diameter of the circle. And which side is it? It's going to be the hypotenuse of your right triangle. And I should also say, and vice versa. So if you have a triangle inscribed in a circle and it is a right triangle, then one of its sides is the diameter of the circle. The hypotenuse of the triangle is the diameter of the circle, and vice versa. So what that means is if you have a triangle inscribed in a circle and you know that one of its sides is the diameter, then that triangle is a right triangle. So let's take a look at a problem dealing with our rule. And I rewrote the rule here. Once again, if you have a triangle inscribed in a circle and it is a right triangle, then one of its sides, the hypotenuse, is the diameter of the circle, and vice versa. So this question here says, in the figure shown, triangle ABC is inscribed within the circle. Given that segment AC has a length of 8 rad 2, what is the area of triangle ABC? A lot of times with rules like this, GMAT, again, they're trying to trick you into making assumptions that you don't in fact know. So from the prompt, we know this side here, the length of 8 rad 2. And then they're asking for the area of the triangle. And so what you might be saying to yourself is, okay, so I know area of a triangle is 1/2 base times height, which in this case means I need to find 1/2 BC, because BC is my base, times my height, AB. You could then say, okay, I just need to find these two things, BC and AB. But you would not want to rephrase your question this way after just looking at the prompt at least, because if you were saying that we just need 1/2 BC times AB, you are assuming that BC is a base and AB is a height. But we, in fact, do not know that this is true from this picture, because they do not tell us that this angle here is equal to 90 degrees. And so if BC is a base and AB is a height, that is only true if this triangle ABC, is a right triangle, and this angle here, ABC, is 90 degrees. So we cannot, if we wanted to rephrase this question, you could rephrase it as something like, if triangle ABC is a right triangle, then what is 1/2 BC times AB? But this is going to be a two-step process if that is true. We need to first determine ABC is a right triangle, and then we need to find BC and AB. And so based on the prompt, really all we can technically do is fill in this value here of 8 rad 2 for AC, which we do not yet know. We do not know this is the diameter or anything like that. It looks like it could be, but remember, figures are not drawn to scale on the GMAT. And so in order to know that AC is a diameter, we would have to know that we have a right triangle here. So statement 1 says x is equal to 45 degrees. So I'll redraw this. That was terrible. Okay, so if we know that x is equal to 45 degrees, what is that telling us? Is that telling us anything that we didn't know before? So if you were to assume that this angle here is 90 degrees, which a lot of people would do looking at this picture, then you would say, okay, x is 45, this angle here is 90 degrees, therefore this angle here is also 45. Now I have a 45, 45, 90 triangle, and therefore I know 45, 45, 90 triangles are in the proportion of x to x rad 2, or if my hypotenuse is 8 rad 2, these AB and BC are my x's, therefore these should each be 8, and then using 1/2 base times height, my area would be 1/2 8 times 8. But we cannot say any of that, because again, we do not know that this angle here is 90 degrees. So knowing that this angle here is 45 degrees does not tell us really anything by itself, because it could be true that this angle here is, say, 55 degrees, which means this angle here would be 80 degrees, which means BC is not really a base and AB is not really a height, and therefore we cannot determine really anything just from statement 1 alone, so this is insufficient. So statement 2, what is statement 2 telling us? Statement 2 is telling us the area of the circle is 32 pi. So area of a circle is pi r squared. And that is equal to 32 pi. So from this we can find the radius. So the radius squared should be equal to 32, and therefore your radius should be the square root of 32. So what can we do from this? Well, we can find, if we can find the radius, we should be able to find the diameter, because the diameter is just twice the radius. So you can sort of see where this is going. If I can figure out that my diameter is equal to 8 rad 2, well, remember, this rule here works in reverse. So this would actually be telling me that I have a right triangle. And so let's see. So if I want to simplify this, I want to find perfect squares that I can extract from rad 32, and this would be the same as 2 times rad 16 times rad 2, and rad 16 is just, square root of 16 is just 4, so 2 times 4 times rad 2, which is equal to 8 rad 2. So this is telling me my circle has a diameter of 8 rad 2. We know from the prompt AC has a length of 8 rad 2, so this is telling us AC is a diameter, and if AC is a diameter, then this triangle here must be a right triangle, because again, the rule here works in reverse. If you have a triangle inscribed in a circle, and one of its sides is the diameter, so one of its sides, AC, is the diameter, then it must be a right triangle. And so, excuse me. So statement 2, if I want to write out what it is actually telling us, is telling us that 2 things. AC is a diameter, and ABC, angle ABC, is 90 degrees. So we can fill that in here. Now, remember, we don't know this information from statement 1, so statement 2 by itself is still going to be insufficient. So now we do know that, after statement 2, we can rephrase our question as what is 1/2 BC times AB, because now we know that we have a right triangle and therefore BC is a base and AB is a height, but we don't know what those values are, and there's no way to find those values just based on statement 2 alone. So now, looking at them together, what do we know? So, looking at our two statements together, we can say, okay, now that I know it's a right triangle, so I'm looking for 1/2 BC times AB. And then for my first statement, I know I have a 45-degree angle here, which means I do have a 45, 45, 90 triangle. So I can fill in the values from my proportion here for AB and AC, and therefore 1/2 base times height, the area of my triangle, should just be 1/2 8 times 8. Which is just 1/2 64, which is 32. So together they are sufficient. But remember, we need to know two things. First, we need to know that we have a right triangle, and then we need to be able to find what BC and AB are. So C is the answer. So that is it for our triangle videos. We will do just one last video filling out our triangle cheat sheet, and then we will do coordinate geometry.